Welcome back, guys. Welcome to the new lecture. So today we will be going to start join section, and this is the first question in joins. Replace employee ID with unique identifier. Okay. So I assume that you are having basic hands-on on joins and the understanding. Okay, the syntax and all that thing. So assuming that, I assume that. So we'll be going into the problem. So yeah, we have been given two tables. Again, we'll read a whole question from top to end. Okay. So we have been given two tables, employees and employees UNI. So in the employees table, we have two columns, namely ID, which is of type integer, and name variable character. ID is the primary key column for this table. Each row of this table contains the ID and the name of the employees in a company. Okay, so that is the employees table, and we have one more table, that is employee UNI. So in this we have two columns, ID of integer type and unique ID of integer type. So yeah, so here in this table, ID and unique ID is the primary key combination of columns with unique values for this table. Each row of this table contains the ID and corresponding unique ID of an employee in the company. Okay, and what they're asking is write a solution to show unique ID of each user. If a user does not have any unique ID, replace just replace just show null. Return the result table in any order. The result format is in the following example, and they have given one example. Okay, so basically two tables, right? Employees and employees uni. In employees table we have ID and name, and these are the employees, right? And employees uni table, they have just the ID. Okay, that is the employee ID, and they have one more unique ID for each and every for some of the employees. And what they're asking is, you have to read this question completely, right? Write a solution to show unique ID of each user. Okay, this has to be underlined, or you have to be sure. Okay, for each user. Again, we have some doubt, right? When we were reading question, user means what? There is no users table, right? User means what? We will get that confusion. Okay, he must have said for each employee, but he has said each user. Okay, he has used the terminology user, but there is no users table or user something kind of, there is employee table. So for that confusion, if you go through the test cases, you will be cleared. Okay, so users means generally he is referring to the employees. So that is the thing. uh, so for every user or every employee, he wants to replace the ID with the unique ID. Okay, so if you see this both these tables, you can see for ID 1, name Alice. If you see in the second table, he does not have any the employee ID 1 Alice has does not have any unique ID. Okay, so unique IDs are only there for the employee IDs 3, 11 and 90. So you can see in the output table, Alice, since he does not have any unique ID, his unique ID is null. And for Bob, he also does not have any unique ID, his employee unique ID is null. And then the other guys, like Mir, Winston and Jonathan, they have their unique IDs, right? 3, 11 and 90 employee ID guys, they have their unique IDs. So the we in the output we have given their unique IDs. So simple thing, right? So this is uh, so here what we are doing is, we are we are taking information from multiple tables. Okay, so whenever we want to gather information from multiple tables, or whenever we want to query information from multiple tables, right? So then the joins comes. So joins is one of the most popular and important and very interview friendly topic, right? So most people actually test on joins. So whenever you are giving interviews for SQL or data roles, people generally this is very favorite topic for interviews, right? So yeah, so joins, right? So if we want to go through right? I'll just go through on a high level like how a join happens, right? So to understand joins, or if you are very in beginner level kind of thing, so to understand joins, what basically we will do is we will be uh, the approach is like, first we will do a kind of cross join, okay? So to understand joins, what we'll do is we'll do some cross joins, and then we will filter out based on our matching key. So that is the way to understand joins. But this is only for understanding purpose, and it is not like the under the hood SQL engine would execute it like that, okay? It is not like that. There are many optimizations that SQL engine would do. It is not like for every join it will do a cross join and like that. But to understand joins, we it is generally recommended to do joining, okay? So first what we will do is we will write the query, and then we will understand like how it is what like how to interpret it, okay? So yeah, now again we will start from okay. So from we have to join two tables, right? From employees, right? From employees, right? From employees. Now join, right? So which join we have to use? Left join, or right join, or inner join, or outer join, or cross join. So we need to be very clear, because that is given in the that is given in the problem statement. So they are saying that we need to write a solution to show the unique ID of each user. So for every user we want to display the unique ID. So for every user will only come when you can see here in this table there are only three matching rows, right? Only three employees were matching, but we want the data for all, okay? Whenever there is no match, we want to display that unique ID with null. So what we're going to do is we can use either a left join or a right join, okay? Because if we use this employees table on the left side of the join, then we will be using left join. So this is the case, okay? Left join and the other table name. So basically what happens is, if I want to, I can use right join by just replacing the names, right? So if I keep employees on the second position, I can just use right join. But in companies and in in real world cases, generally we most 90% of the time we use left joins only. Right join, it is very unlikely that you will see a right join. But SQL has provided it. You kind of you can use it, but mostly people just go with the left joins, okay? Now from employees left join you employee UNI, right? So what we will do is we will first try to understand uh, yeah. So left join on employee UNI, and then we have to give some key, right? On which key this has to be matched, okay? On which key this has to be matched. So we'll be giving the common key, right? So the common key is ID. ID is common in both the tables. Like ID is the primary key. ID is the primary key here in the employees table, and ID is acting as a foreign key in UNI table, right? It is referencing to the primary key of employees table. That's the foreign key, right? So yeah, basically you have to remember that most of the time whenever we do join, we will be giving like what? We'll be giving one primary key, and we will be giving the key which is primary key of one table, and it will be the foreign key. It will be acting as a foreign key of the another table, right? Here ID, right? ID is the uh, primary key of employees table, and ID is the foreign key in the employees UNI. So basically, if I give on ID equals to ID, SQL engine will never accept it. So basically, what we do is we will be giving either the table names. Okay, we will be giving either the we can be giving we can give either the table names directly like this, or the easiest way is to give aliases. Okay, so here what we are doing is I'm just giving an alias. Okay, SQL understands this. So this is the syntax to give an alias. I hope you are well aware of it, but I'm still covering that. So this is the alias. So what we can do is simply we can use this alias. Okay, so this alias can be given to table names, and also the subqueries that we write. Okay, so in coming lectures we'll be saying that also. So what I'm doing is I'm just giving the alias. Okay, it simply means that I want to match on column employees. Okay, this E means it is employees.id, the ID column in employees table, and EUNI means this employee UNI table, the ID column in employee UNI table. I want to this both to be matched. Okay, and now if I do a select star, okay, if I do a select star on this, and if you see the output of it, let's watch the output. So you can see both tables have been joined, right? So both tables have been joined. So what happened exactly? The first three, right? Uh, okay, 3 Jonathan has been joined with 3 1, right? Because both the IDs are same, right? And 11 Mir has been joined with Mir IDs 11, and Winston has joined with his particular ID. And you can see Bob and Alice do not have any matching ID in the employee unit table. That's why their rows in the right table is null. Okay, so the first we have got the left table rows, and on the right side we got the right table rows. So the right table rows for the non-matching records we have got a null value for it. So now what they want us to display is they want us to display the unique ID and the name. Okay, the unique ID and the name. So if you go to code, see, the unique ID is in the second table, right? The unique ID is in the second table and name is in the first table. So we need to be very clear. Okay, so first we need to get the unique ID that is in EUNI table, right? I want the unique ID and I want the employees date name from the first table. Okay, just be clear with the these things. So basically I can emit these two aliases because you will be not be getting any uh, error until and unless it is an ambiguous column. Okay, so if I try to print ID, I'll be getting, right? So these two, I'll be just see if I try to print the ID. Okay, if I try to select ID, so this will give me an error. Okay, because ID is an ambiguous column, because ID is present in both the tables and SQL doesn't know which table it has to it has to take from. Okay, that is why we'll be getting column ambiguously defined. So for the columns which are common to both tables, we need to definitely use this aliases so that SQL understands where it will be coming. But for the unique names, we either we can use the alias or not. Okay, because you can see name and unique are unique ID column names are just in their own tables, and they are not present in the different tables. So you can see it has run correctly. Okay, but the best practice is in the SQL and in the whole industries, it is always best to use the aliases, because it is very good in readability. Okay, we will be in real world we'll be having a big query which will be having hundreds and hundreds of columns. So it is better to write the column aliases, because we'll be getting to know from which table it is coming from. Okay, so it is always best practice to use the column aliases. So now if we run this, uh, see, you can see it has passed. And now if we submit this, yeah, it has passed. And yeah, cool. And also if we can check the other solutions, yeah, this will be very pretty similar. So yeah, this is the join, this is how we do perform joins. Okay, this was the first question. But if you are still not clear how join is happening, or if you want to interpret line by line, I will just be explaining you on a in some uh, high level point of view. So what we'll be taking is, like, we'll be interpreting like what is happening behind the scenes. Okay, so basically uh, assume that whenever, to understand these joins, right, like how the join is performing, like we will understand with the cross join example. So what we will do is we will be I will be walking through this whole process, like what happens. Okay, so basically what happens is whenever you say this join, right, like this is table employees, right? So this is the table employee, very sorry. So this is the our employees table, and this is our employees UNI table. Okay, so generally what happens is whenever you say, right, employee join employee UNI, so what happens is basically under the hood, every row in first, okay, every row in one table will be mapped with every row in the second table. Okay, so this first one and allies will be mapped with the second first with the first row of this first column, and again he will be mapped with the second row of this table, and again he will be mapped with this row. So like it is like a nested for loop. Okay, so every row from one table will be mapped with each and every row from the second table. So this is the this is the cross join example basically. Okay, so what happens is each and every row, okay, each and every row in first table will be mapped with every other row. Okay, so this is what will happen in the joins. Okay, so we will see the output of a cross join. Okay, this is what happens in the cross join. So what we will do is, very sorry, I've started with select. Okay, from employees, okay, employees e cross join employee UNI. Okay, I'll just select star. Now I will run this query. So you can see the output. I'll just copy this output and I'll paste it over here. Oh, what's happening? Yeah, I'll paste it over here. Oh, 1 second, I think it didn't crop it properly. I'll copy this output, capture, and I will paste it over here. Yes. So now you can see that what happened is every row from the first table, that is Alice, has been mapped with each and every row, right? So once again, basically I think it was the either way. Okay, so you can see here. So first, so just understand like this. Okay, it is not like exactly like what I have said, but you can see here the first row on first table has mapped with this thing. It has attached with the 3 1, and then again the second column has attached with the first column. All right, and again mayor as also with the attached with the first column, and then the fourth one as also attached with the first column, and then fifth one. You can see this: Alice 3 1, Bob 3 1, mayor 3 1, Winston 3 1, and Jonathan 3 1. So for every first row, basically it has happened the either way. Okay, so I've said like it is like a nested for loop, right? So for every iteration of the first, right, for outer loop, the inner loop will be running for n iterations, right? So now for 3 1 has been mapped with all the employees table. Again it will happen for the same. Okay, again again if I take another color, Alice will be mapped with 11 2, Bob will be mapped, and again for 11 2 Mir, you can see 11 2 again Alice, Bob, Mir, Winston, Jonathan. Again for 90 and 3 we have Alice, Bob, Mir, and Winston and Jonathan. So you can see that um, you can see that this is what happens on the first phase. Okay, so once this cross join has been done, once this join has been done, okay, once this join has been done, now if we see our query, if we see our original our query, so not this, oh, not this. Arre, there's something that's happening. My god, something is getting pressed. Oh my god, it's not selecting properly. Yes, so now this is the query, right? So select EU, this is the query, right? From this, join this, right? Now what we are saying is we want the condition, I want only the rows where employee ID is equals to EUNI, right? So I want the only the rows where employee ID, okay, EMPID dot EUNI ID. So basically this is the this is the employee ID, okay, this is EID, E.ID, and this is employee unique dot id, okay, this is EUNI ID. I'm very sorry, just remove this, and this is EUNI dot id. So what my on condition is saying EID should be equals to employee UID. So you can see here EID is not equals to our employee ID. Here also the same thing. So once we join this, once we do a cross join, then it is very easy to compare, right? So here also it is not equal, here also it is not equal, and here also it is not equal. So basically for 3 there is nothing that is existing. And then what we are doing, here it has matched, okay, this row has been matched, so this will be on the output, right? 3 and Jonathan, okay, this row has been matched. Now next compare again, 11, here it is matched, right? 11 and Mir has been matched, right? And now again we will see 90 and 11, 3 and 11 no, uh, coming to now 11 has been matched, 3 has been matched, and coming to 90, you can see 90 has been matched over here, okay. So these 3 records will be coming out if I do a normal join, normal inner join, if I don't use left join, and if I do join only simple join, right, I'll be getting that result, okay, that those 3 records, 3 Jonathan, 11 Mir, and 90 Winston, okay. So you can see, so we have got these 3 records, Mir, Winston, and Jonathan, who have been there, okay. So this is how like we can interpret the join, like you by using cross join, okay. So whenever we get a join, we can just do a cross join, and then we can go on checking the values whichever there on the filter, okay. This is on condition, right? On condition we can use that filters and we can take out. So this is just for the interpretation, and it is not like how SQL performs join, okay. SQL does not do a cross join, it will do it has some optimizations to perform joins, so it will do all those things, okay. So it will not do any cross join like how we have interpreted. This is only for understanding purpose. Now what happens is we have used not join, but we have used a left join, okay. So left join means what it does is it will it will uh, it will give all the records, it will give all the records from left table, okay. It will give all records from left table, so it will give all records from left, okay, and only matching records from right, and only matching records from the right. So this is the thing, okay, the left join thing. Now you can see the left table is this and the right table is this. So here if you see properly, uh, okay, this is my right table. So by this statement what I mean that all records from left table and only matching records from right table, that means I will be in my output table, right? In my output table, suppose this is my output table, okay? This is my output table, right? So I'll be getting all the records, okay? I'll be getting all the records from my left table, okay? I'll be getting all the records. Suppose I have this 1, 7, 11, 90, and 3. So, okay. So in my output table, I'll be getting all the records from my left table, and the corresponding value, that corresponding row from the right table, right? The corresponding row in the right table, I'll be getting only the matching rows from the right, okay? So this statement, and only matching rows from right means I'll be getting the value for these for the left table column. I'll be getting the values from right table values only if there is a match, and if there is a no match, if there is a no match, those rows, okay, those values will be coming as null, okay? So if you see 11, 90, and 3 were having, where they were present in the unique id, so they'll be getting their unique id, okay? So as there was a match, okay, when we have performed join, they were matching, right? They were matched, so we'll be getting corresponding unique id. So 11 unique id was 2, and 90 unique id was 3, okay? And 3 unique id was 1. So this is the meaning of that statement. We will be getting all the records from left table and only the matching records from the right table. That means we will be getting, when we do a join, we'll be getting only the matching records, and for the all the non-matching records, the right table values will be none, okay? So here we'll be getting null for all the non-matching tables, okay? All the non-matching rows, I'm very sorry, rows. So you can check the output table. For all the non-matching records, the unique id was null, okay? And wherever there was a match, okay, their right table values were 1 to 3, okay? We've got the values. So I hope you understand. Yeah. So this is the solution for the problem, guys. So in so I've used the cross join example to show you how to, how you can use a cross join example and interpret or understand what's actually happening behind the these joins. So but once again, I want to make it very clear that this is not how the SQL engine actually executes the query internally. So the engine would perform some of the optimizations techniques to execute the queries efficiently. So it doesn't perform a cross join for every other join, okay? I just wanted to make sure that, again and again, I want to make it clear, in right? So also, I know that this video has gone beyond 25 minutes, yeah, right? So it's a bit longer than usual, but I believe it's worth spending extra time on these fundamentals at this earlier stage, right? So if we understand these fundamentals, if we are strong and we have a very good grip on this, right? So later when we are solving advanced SQL problems, right, in this SQL 50 series, then it would be very easy for us to then it would be very easy for us, and it would be much easier with this concept if we are strong with these kinds, because the problems that we have been solving so far, this problem and the next couple of problems, um, there are these are all straightforward joins. Like what we have done is we need to just join, and we need to bring some information from one table on using a matching key, right? So in this problem we have id and name, and we have id and unique id. What we have done is we have matched we have joined these two tables on matching key, that is id. And then what we are doing, we are selecting, right? We are projecting, selecting and projecting. We are reporting, projecting, or selecting. We are giving the name and unique name. So it is a simple straightforward join. But later we will be having problems like, you have to join, and then you have to perform some group by, and then otherwise else you have to like do some aggregation or use some window functions, etc., etc., right? So at that particular time, we would be we would be very thorough on these joins. Then we can focus on the remaining part of it. So at that later when we're solving, when that solving time will be very smaller, because we have already we have already put our time learning here, right? That is what I want to just say. This is from this problem. and I'll meet you in the next problem. Thank you.